All right, so we're gonna be solving a little physics problem here, and this one that we've got is essentially a man pushing against a piano. I know it's a beautiful piano, right? And so he's pushing against it and keeping the piano at the exact location that it's in without sliding down a 14-degree ramp. So we have a mass of 190 kilograms on a ramp with a 14-degree incline. The mass does not move down the ramp, therefore, an acceleration is pushing against it. So, how hard does the man have to push against the piano in order to keep it where it is? So, this is pretty pretty straightforward when you get right down to using Newton's laws. So we're going to use a lot of Newton's laws in this problem. And you can feel free to draw your diagram either like this or something like this, where you have an off kilter uh, diagram. Either one should work for you just fine, but one may require more steps than the other. So for the purpose of this particular video, we're going to work with this axis right here. So, first things first, we're going to find the force along the x-axis as though he's pushing directly this way and not, at the 14-degree incline towards it. So, what do we know? We know that gravity exists. So, that's cool. So, we'll draw a box here, color it in a little, and we have gravity facing directly downward. And the acceleration of gravity is 9.8 meters per second squared, but I'm not going to write that out. And we also have our incline of 14 degrees. That was a weird way of writing 14. Okay, so what do we know about the laws of physics? We know that every action has an equal and opposite reaction. If not, this object would fall through the earth. So there must be an opposite reaction pointing up. But when you have an incline, there is a normal force that points upward perpendicular to the hypotenuse. So remember that. And this is going to be equal in acceleration to gravity. So we know that. Now we draw a line directly upward from our gravity line, and now we connect it. So we draw essentially like this. We know this is a right triangle. And so what do we know about this? Well, we know if we were to draw a line right here, that this is 76 degrees. I'm not going to go through the proof of this, but we know that based on the triangles that we're working with here, that this angle right here is going to be 14 degrees, and this angle right here is another 76 degrees. So at this point, what you're doing with is trigonometry. So we're trying to find the force coming from the x-axis. So we want to find this up here. We want to find, relative to the 14 degrees, we want to find the opposite. So in order to find this, we need opposite, and then we look at what our knowns are. We have a 9.8 on the adjacent of the 14 degrees. So opposite over adjacent, and we know that opposite over adjacent is tangent theta. So you have opposite over adjacent equals tan theta. And our theta in this case is going to be 14 degrees. So I'll start writing it over here. So tangent 14 degrees equals our opposite, which is 9.8 over our adjacent, which I will now label a of x, because that's the acceleration along the x-axis. So this means that a sub x equals 9.8 Shoot, I did the opposite over adjacent part wrong. That's my bad. It's supposed to be a of x over 9.8. I got confused and thought that it was the other way around. That's my fault. But basically, this is going to be 9.8 tangent 14 degrees. And that's going to be equal to a of x. So pardon me, that's just a little bit of mathematical tinkering there. And so we have our 9.8, and basically just use a calculator for this. I'll just real quickly figure that one out. So that's going to be 9.8 tan 14. And we end up with 2.4 meters per second squared. Okay, so we have our acceleration along the x-axis. Now, we plug this into F equals ma, and that's going to be 2.4 times the given mass of 190 kilograms, which is going to result in, that's going to result in 456 newtons of force. And we know that for every action there is an equal and opposite reaction. That's the force due to gravity pushing along the x-axis. If this block is to not move, the man must push with an equal amount of force in the x-axis. So we know that 456 newtons is our answer.